Hey guys, welcome back. So in this video, we are going to discuss how we can change the speed of induction motor. Though it's a very difficult process and normally not done on ships, in some cases we still are required to change the RPM of induction motor. And how are we doing that? Let us see. To change the speed of induction motor, we need to change the speed of RMF. That is the main requirement. We need to change the speed of RMF, rotating magnetic field. And this rotating magnetic field is rotating at this speed. That is synchronous speed. And we know the formula now. It's equal to 120 F upon P. That means there are basically two ways we can change this rotating speed of RMF and then the motor, that we either change frequency or change the number of poles.
Induction motor speed control is done with variable function drive, and I guess that is why you're watching this video. Very important. In a lot of shipping companies interviews, these questions have been asked. So I hope you like it. In case you're looking at joining the right college, right company ASAP, then why don't you come to SMED Marine Academy for offline coaching, ताकि results fast हो जाए. In case you cannot come, then in that case you can buy our ETO Aspirant Excellence package at Merchant Navy Decoded platform. What are you waiting for? The link is in the description box. You can always check out the trial videos. Jai Hind, Jai Bharat, Jai Mata.
On ship, the frequency is 60 Hz, that is fixed. So with the supply frequency directly coming to the motor, we can't change the frequency like that. Similarly, once the motor is made, it is already constructed, then we simply can't rearrange the number of poles in the stator. So that is also fixed. So that is why this thing is fixed. Means synchronous speed is fixed. RMF speed is fixed for a motor. It can't be changed. But let's say if we have to change it, then it is either by changing frequency or number of poles, we can change the speed of induction motor. So two methods: variation of supply frequency and variation by changing the number of poles. So let us see, though it is difficult, but frequency can still be changed. How do we do that? It is called VFDs, variable frequency drive. So some of the cases we do change the frequency. Even though this may not be really efficient process, we may end up losing some energy in that, but still if this is really required, we'll do it. Okay, so let's see how do we do that. So this is an overall view. We are not going into too much details how this is happening, but just to give you an overview how this can happen, let's see this. So first of all, this is the motor and this is the incoming power, 60 Hertz. Now, suppose I want to decrease the speed of induction motor, let's say half. So I'll decrease the frequency by half, let's say 30 Hertz. How do I do that? So first of all, I need to convert AC into DC. And then this DC, I am converting back to AC using inverter. So you remember, if you know that we use to convert three-phase AC to DC, we use three-phase rectifier. So we have already studied this part. This is how three-phase rectifier will be there. 6 diodes are there. We have exactly worked on this in my previous videos. We have shown you this. Filter is for smoothing, and finally what we get is this and this DC current going in. So this is plus and this is minus, and now this is to be further converted back to AC. In your house you have inverter. Some of the houses in some of your houses you may be having inverter where there's a power cuts in those areas frequently. And what inverter does, it take DC from battery and is converting back to 220 volts AC of your house. The inverter is reverse of rectifier. So this is an inverter, and this is using some kind of transistors. Since we have not studied these transistors, these are specific name is IGBT. Okay, insulated gate bipolar transistors. So these are transistors. So these are switching device. So they will take DC, convert to AC. Now, how I am controlling these transistors is in the hand of a controller. Controller will be triggering those switches, and that is converting this DC to AC. Whatever frequency you want, this is going to do that. So everything is happening here, but this needs input as a DC. So DC is you're getting from three-phase rectifier. So this is how an VFD will work, variable frequency drive. And where do you use this thing on board ship? There are chemical tankers in which there is a motor fitted on the deck and the pump is inside the tank. These induction motors, we need to run at different speeds so that I can change my delivery or volume per hour. Means I need to change my delivery rate for these motors. I can speed them up, I can reduce the speed. This is required. So that's why one of the company called Marflex is making such pumps where using a VFD, I'm driving those deck mounted pumps in a chemical tanker where cargo pumps are inside the tank and motor is on the deck. In engine room, there's a machine called incinerator which is burning sludge, and maintaining that is to be maintained around 900 to 1100 degrees Celsius temperature. So how the temperature is being maintained? If the temperature is falling, you need to increase the delivery feed rate of the sludge, and that is coming through a positive displacement pump. So if you increase the RPM of the positive displacement pump, the feed rate of the sludge which is to be burned will increase, and when the temperature was falling, it will again start to rise. And vice versa, if the temperature is increasing too much, you need to reduce the RPM of the pump. That means using a VFD, you are controlling the speed of this motor, which is connected to the feed pump of the sludge, feeding the sludge into the burner of incinerator. These days, gentlemen, there is too much of talk about energy saving. So we are now developing more and more such systems on board ship. When the flow rate is not required enough, you can reduce the speed of these motors. For example, engine room blowers. When the ship is in port, you don't need too much of airflow into the engine room, which earlier when the engine was running, air is needed for burning the fuel in the, so air will be sucked in turbocharger. Since you are in port, main engine is not running, so this amount of air that is earlier required the requirement is less. So you can reduce the speed of the blowers. Earlier we used to stop the blowers when not required. Nowadays, using VFD, we can reduce the RPM of these blowers so that less amount of air is introduced into the engine room. Okay, so these are few examples. There are many more such examples coming these days. Just for the energy saving, we are employing those. Okay, so this is all about VFD, gentlemen. In the further module, we are going to discuss about one more method that is called pole changing method. Okay, so see you in the next video.